Hi, we're here with my friend Alan from UC Berkeley, and we have a project that they were working on over there that actually involves a flywheel on a go-kart. Alan, most go-karts don't have flywheels, and you actually designed this one and built one. You give our viewers a little bit of an idea of what, why you put a flywheel on a go-kart and how you designed it.
Well, the purpose of the flywheel is to improve the regenerative braking efficiency of this hybrid electric vehicle. And the design of the flywheel was based primarily on safety factors. So outside the flywheel is this giant aluminum casing, and we did FEA analysis along all the bearings and all the parts of the flywheel. So for most electric vehicles, there's standards that recommend at least a 4 or 4.1 factor of safety, but based on our tests and our calculations, our flywheel has a factor of safety of 5.3. Yeah, so that was basically the motivating factor behind every single part of the flywheel design, just safety.
And this particular flywheel, it looks a lot like an electric motor, really. Can you give us an idea of what the internal parts are kind of comprised of?
Well, the flywheel actually is part of a custom motor that was built in-house. So the flywheel is attached to the rotor of the motor, and the rotor also has the permanent magnets, which are right here attached to the kart, just for demonstration purposes. But there's more inside there. There's a total of 24 of these guys. And the coils of the motor are in the stator of the flywheel. So what happens is, during regenerative braking, the system pulls current away from the traction motors into the flywheel's coils, and then that will start spinning up the flywheel. And then after a certain point, when we want to accelerate again, it will switch the terminals to this flywheel motor, and the flywheel begins acting as a generator because all the energy gets stored in its inertia, in its rotational energy. And then when it acts as a generator, it starts pumping current back into the two traction motors, which means it draws less current from the battery packs. And then this just basically helps the overall efficiency of the system and improves the battery life of the two packs. The host UI for the go-kart, and on the left side is flywheel RPM, and on the right side is the system current flow to and from the battery packs. So red would be the current draw from the battery packs, and green is the current being sent back. Now this is just for demonstration purposes only. It's not exactly how the kart would behave in a real situation, but it's just to showcase the regenerative capabilities of the system. Okay, so here the flywheel is just spinning up by itself, and you see how it draws current, and when it brakes, it sends current back into the battery packs because the motors aren't running. But now when the motors are running, after a certain point, when the flywheel brakes, the motors will draw substantially less current just for a split second, because at that moment the power is being supplemented by the flywheel, so it draws less from the battery packs.
About how fast does the flywheel spin at max speed?
Okay, well, the flywheel was designed for a max speed of 25,000 RPM. All of our tests were conducted at 11,000, just again for safety reasons. And today, all of the demos are only at 2,000 RPM.
What's the max power rating for the flywheel?
The flywheel is rated at 2.5 kilowatts at 11,000 RPM.
And of course, this is a National Instruments design competition.
Yeah.
Where's the National Instruments equipment in this design?
The National Instruments equipment is all in the front of the car. There's a C-Rio and a CAN bus. So the C-Rio basically handles all of the signals that come to and from the sensors and the motor controllers. So there's pedal position sensors for both the throttle and the brake. There's all the current and voltage measurements for every single one of these motors and in and out of the battery packs and stuff like that. And then the CAN bus sends signals to the three motor controllers. There's a motor controller for each rear wheel and one for the flywheel.
What's the next step for this project? What are you guys doing on it now?
Next steps, well, there's many places for improvement. So we are actually redesigning the battery packs right now to try to basically larger capacity, less weight, just a lot of optimizing these parameters. Probably the biggest thing would be the control code on the kart, because currently we're only running open loop control because PID control just was too unstable. There was a large current overshoot when we sent braking back, or during regen braking, when we sent current back, it would overload what the battery packs can safely accept. So we just for a split second, but we wanted to minimize that. So with open loop control, it sent a prediction of what current to expect, so the flywheel could anticipate that and draw more current rather than letting it flow back into the batteries.
Gotcha. Well, it's an interesting work, Alan. It's quite a project. It must have been fun working on it.
Yeah, it was definitely a great experience for me and the rest of my team.
Great. Thanks.
All right. Yep, no problem.